Audio Jungle. Audio Jungle. Audio Jungle.
A general-purpose computer CPU consists of a control unit which is defined to generate a unique set of control signals for every instruction in the instruction set. It also has a set of registers to store data and instructions. It also contains arithmetic and logic unit to execute arithmetic and logical instructions. Instruction set is the software component of a computer system. Usually a computer programmer writes codes in high-level language like Pascal or C, and what make them to connect to the machine is the instruction set. It also consists of machine instructions, the low-level language, which are in binary language. Machine language is the language which can directly run on the CPU. They are numeric, that means in series of bits which are zeros and ones representing instructions that a computer can understand them. This makes it tedious and error-prone to write machine code manually. They are not portable, means a machine language is specific to a particular type of machine only. Ultimately, all languages need to be translated to machine language. On top of that, we have assembly language. Assembly language helps eliminate much of the error-prone and time-consuming machine language programming. It replaces remembering 1 and zeros with instructions which are mnemonic codes for corresponding machine language. For example, it has commands like moves, jumps, cmp, add, and etc. Each assembly language is specific to particular computer architecture and sometimes to an operating system. Example includes MIPS, NASM, and x86.
High-level language is written in English, and it is easily understood by a human. The programmer can write programs easily using high-level language. It is not understood by the computer. Examples of high-level languages are C, C++, Java, Python, etc.
Machine language is read by the computer's central processing unit, CPU, is composed of digital binary numbers and looks like a very long sequence of zeros and ones. Each CPU has its own specific machine language. The processor reads and handles instructions, which tell the CPU to perform a simple task. Instructions are comprised of a certain number of bits. If instructions for a particular processor are 8 bits, for example, the first 4 bits part, the opcode, tells the computer what to do, and the second 4 bits, the operand, tells the computer what data to use. Ultimately, the source code of every human-readable programming language must be translated to machine language by a compiler or an interpreter, because binary code is the only language that computer hardware can understand. There are 2 ways to do this, and they are related to how the program is executed. A high-level language can be compiled or interpreted. High-level source code contains easy-to-read syntax that is later converted into a low-level language, which can be recognized and executed by a certain CPU. High-level language cannot be understood directly by a computer, and it needs to be translated into machine code. Each of these languages use different syntax. Some are designed for writing desktop software programs, while others are best suited for web development. But they all are considered high-level since they must be processed by a compiler or interpreter before the code is executed. Source code written in languages like C++ and C# must be compiled into machine code in order to run. The compilation process converts the human-readable syntax of the high-level language into low-level code for a specific processor. Source code written in scripting languages like Perl and PHP can be run through an interpreter, which converts the high-level code into a low-level language on the fly. Computers only understand machine-level language, i.e. the zeros and ones. So when we write anything in high-level language, at first it is converted to its internally mapped unique code, which is further converted to binary. Assembly language, which is a type of low-level language, and high-level language are vastly different. In assembly language, programs written for one processor will not run on another type of processor, but in high-level language, programs run independently of processor type. Performance and accuracy of assembly language code are better than a high level. Due to long executable code, high-level programs are less efficient than assembly language programs. In order to that, high-level languages have to give extra instructions to run code on the computer. Code of assembly language is difficult to understand and debug than a high level. While in high-level language, it just need one or two statements of high-level language to expand into many assembly language codes. In assembly language, we can directly read pointers at a physical address, which is not possible in high-level, but high-level language require to insert specific code or commands to read pointers. Lastly, assembler is used to translate code in assembly language, while the compiler is used to compile code in the high level. A high-level language programmer does not need to know details about hardware like registers in the processor as compared to assembly programmers. High-level languages are much closer to the logic of a human language. It is necessary to analyze the differences and is widely advised to use high-level language for programmers or learners. A high-level language uses a set of rules that dictate how words and symbols can be put together to form a program, which are commands, syntax and logic, which correspond closely to vocabulary and grammar. The second advantage is that the code of most high-level languages is portable, and the same code can run on different hardware. Portable code in a high-level language can run on multiple computer systems without modification. They are easier to read, write, and maintain. Programmers write in high-level languages because they are easier to understand and are less complex than machine code. They allow the programmer to focus on what needs to be done, rather than on how the computer actually works.